Thank you. So now Ken Paulson is going to join us. Ken is with the BC Oil and Gas Commission, and Ken's been in the oil energy business for a while. So he's going to talk to us today from the perspective of a regulator. And this is absolutely one of those areas where there is a lot of regulation. It's perhaps a bit different than it is in the human health area, where regulations are codified and changing them requires an active eye. Here the regulators work a lot closer with the various stakeholders in terms of doing things, so they are absolutely part of the equation to getting things implemented into the system. So,
Good afternoon, and thanks very much for the opportunity to be here today. Kind of wondered when we were invited, you invited a civil engineer with a background in pipeline engineering, really young modulus and steels, to talk about genomics, and so I assumed that was the entertainment for the afternoon, and you'll see that in my presentation as I walk through a little bit. But I will try to draw some linkages, I think, where there might be some opportunities for biology into the what we normally have traditionally considered the hard and fast engineering side of the oil and gas sector. So I started out by doing some in-depth research about genomics and the oil and gas sector, which I understand, and I came up with these two slides, which are self-explanatory and showing the similarities between our two fields. I think and then I did some reading, and there's actually a very good paper out there that provided me with some comfort, and it was done by Genome, I believe. But and there's a quote from there that says, "Genomics research is relatively new to the energy sector, and its potential applications are poorly understood by regulators, industry, and other sector stakeholders." So I took a lot of comfort in this slide. And moved on from there and said, well, okay, so let's assume the audience is way smarter than you on this topic. So maybe what we could do is talk a little bit about what's happening with oil and gas here in British Columbia, and let you folks fill in where some of the opportunities may lie. So we'll try that and see how it goes. And so I apologize in advance for my talk. So the Oil and Gas Commission, the British Columbia Oil and Gas Commission, was created in 1998. So as regulatory agencies go, we're relatively young at I think 17 years now, going on will be 17 this year. Our vision, like every regulator's vision across Canada, is to be the leading oil and gas regulator in Canada. We've been in operation, as I said, for 17 years. We're responsible for regulating oil and gas activities in BC. So what that means is essentially from the reservoirs, so from the reservoirs and the geophysical exploration and identification of the subsurface resource, the seismic investigation, identifying where a reservoir might be, to the exploration, to the production, to the processing of fluids, be they gas, liquids, or a combination of the two from the reservoir, processing of those, putting them into the transmission pipelines that deliver them down to Vancouver, into Alberta, into the US, and including at the far end of those pipelines, liquefaction, LNG, as well as potentially some offshoots. They're looking at expanding our portfolio to include things like methanol creation, methanol production. So we were created to be a single window. What that meant was if you're working in a lot of sectors in British Columbia, you have to go to the Ministry of Environment for this permit and authorizations. You have to go to the Ministry of Forest, Lands, Natural Resource Operations for this authorization. You might have to go to the Ministry of Energy and Mines for this authorization. In the oil and gas sector, we were created to be kind of a one-stop shop for all of those provincial authorizations. So about 98% of the permits and authorizations required to develop an oil and gas play in the province come through our shop. So in that role, in terms of the permits and authorizations, we're a lifecycle regulator, a full lifecycle regulator, so we ensure public safety. So the bulk of our regulations are actually post-permit regulations, which deal with safety and protection of the environment associated with oil and gas activities. Protecting the environment, compliance enforcement, reviewing and assessing applications. And the last bullet's kind of interesting. So if you're in Alberta, what you find when you're proposing oil and gas projects to the regulator there, who's recently gone to a one-window model as well, called the Alberta Energy Regulator, you would find that you have to do your consultation with First Nations in advance of submission of your application. I think it might be changing in Alberta, but that's been the model for years. Here in British Columbia, we're encouraging folks to go out and engage with First Nations in advance of submission of their application to us. But we actually carry out the consultation and ensure that the duty of the Crown is carried out in terms of effective consultation of the Constitution. So we really are kind of a soup to nuts shop for oil and gas here in BC. And what is oil and gas here in BC? So, telephone. So what is oil and gas here in BC? So what's interesting in the last little while here in BC is year over year, we've been seeing slight increases in natural gas production from the province. So I joined the commission in it's not related to me joining it, but in 2009, by now, we're actually producing, we were producing about 25% of Canada's gas from British Columbia. I was told we had 20 minutes. So that's okay. So it's a good warning for the 5 minutes. So yeah, and so 25% of the gas, Canada's gas in 2009. Today we're producing about a third. And we continue to increase, actually. So increasingly, gas is coming from British Columbia and supplying North America. It's declining, though. Canadian exports to the U.S. are declining, and they're declining dramatically. They declined like 14 or 18% last year. This slide up here is from the Energy Information Administration of the United States, and it's kind of telling these are pipeline imports of natural gas to the United States, who, as you might guess, is our only export market. And they're saying that by about 2020, they won't need Canadian gas. And it gets even more interesting because then it goes negative, which means that actually they'll be displacing Canadian gas, and we've already seen that in Ontario. So it's interesting times in gas markets in North America. So couple that with the fact that we have a huge resource here in British Columbia. So we have, we talk about geologists, engineers talk about gas in place, and they talk about reserves. So gas in place is the amount of gas that could actually be in the rock. 100% of the gas is in the rock. We talk about 2,900 TCF or more of gas in place here in British Columbia. So what is 2,900 trillion cubic feet of gas? Well, today Canada produces about 5 trillion cubic feet a year. So give you an idea of how much resource we're actually talking about. Most of the resource here in BC is up in the northeast, and this slide shows what we commonly refer to as our 4 unconventional basins, the largest of which is the Montney Basin, which is centered around Fort St. John and Dawson Creek. You can see that, and this is as of July of last year, daily production from the Montney was around 2.4 billion cubic feet a day, and again, to put that in perspective, total production in British Columbia is around 4.5 billion cubic feet a day. So more than half of our gas is coming from the Montney Formation, and that was in July and continues to increase. So we talk about unconventional gas and unconventional reservoirs. They really have become conventional. The bulk of our gas, 75% of the gas we have in British Columbia, comes from an unconventional reservoir. That's a reservoir that is developed using horizontal wells and hydraulic fracture stimulation. So 75% of the gas that we produce in BC is coming from those resources. So, and that's increasing constantly. And it's been that way since about 2010. So the bottom slide graph in the corner, there's an orange line and a green line. You can see they cross in about 2011. And that's when unconventional production in British Columbia actually became more than conventional production. So in perspective, when we talk about things like hydraulic fracturing and waiting to see, to study, and do more work on, keep in mind that 75% of our production is dependent on hydraulic fracturing today. So. I've talked a little bit about Lifecycle. British Columbia is not overly developed in terms of oil and gas right now. We have about 21,000 wells. Compare that with Alberta, which has over 100,000. We have a network of about 40,000 kilometers, give or take, of gathering and transmission pipelines that are regulated by the province. Compare that to Alberta, which is closer to 300, a little over 300,000, I think. You know, but the nice thing about it is that because it's a relatively young industry in BC, it's relatively modern technology as well, which is, I think, a benefit for BC. This slide shows how you might develop an unconventional play, or how we are developing unconventional plays up in northeastern BC. Contrary to popular opinion, the actual footprint associated with unconventional gas and hydraulic fracturing on the land base is less than you had with conventional gas development. The subsurface footprint is considerably more. So the subsurface footprint, the whole concept is to go in, access those shales, which in the Montney are between 1,500 to 2,100 meters below the surface, fracture them to create fissures to allow the gas to flow, and then collect the gas at the surface. So, of course, in doing that, you need water for the hydraulic fracturing. You need to store the water, you need to treat the water and recycle the water, and you want to reduce the amount of water that you're taking from streams all the time. So that was probably an area where there might be a link to biology. Looking ahead, so there's been a lot of talk in British Columbia about the development of LNG. Certainly the Premier has laid out a base case for development of 82 million tons per annum of export capacity here for BC. 82 million tons, again, to put it in perspective, would require about 11.6 billion cubic feet a day of marketable gas as feedstock. So, and then that would equate out to about 15 billion cubic feet a day of raw unrefined gas production. Remember, I said we're producing about 4.5 BCF a day right now, so that would be triple the production if all the gas were to come from British Columbia to supply the LNG industry at 82 megatons per annum. So we did a little bit of a forecast with the Ministry of Natural Gas Development and assumed that if 75% of that feedstock were coming from British Columbia, what would be the effect on activity up in the northeast or in the oil and gas sector? We ran the numbers, and it's interesting since I started in this business again in 2009 in BC, and was with the National Energy Board before that. But the average production from a horizontal hydraulically stimulated well has increased more than 700%. So, and that's without biology. That's just based on sheer energy and frac sizing. So, and it continues to improve, although they're very productive today, evidenced by the amount of drilling that we're seeing and the fact that we continue to produce increasingly more gas on the Canadian scale. So, anyway, back to supply 82 megatons per annum. Drilling activity in BC would peak, assuming that that the delivery capacity came on stream, the 82 megatons was required by about 2020. By 2019, in order to fill the pipes to deliver that gas, we'd have a peak year of drilling of about 2,100 wells, which is actually very manageable in terms of a regulatory perspective, in terms of a hardware perspective, in terms of a land-based perspective. Associated with those wells and that development, you require about 43 million cubic meters of fresh water, and that's assuming about 20% recycled. So. Of course, the higher the use of recycled water, the lower that number would be. But in perspective, that usually when we talk about water availability and allocations, we talk about 15% of the mean annual runoff to be available for allocation for industrial or agricultural or human purposes. That 43 million cubic meters amounts to less than 0.17%, I believe, of the total available water allocations. So considerably less than what the land base can sustain for water, and again, despite what you may have heard. So some of the areas, I think, where there are some opportunities and some linkages, and Steve and Uli both spoke very eloquently about creating fuels and cleaning up after fuel spills. And certainly those are the two areas where I see opportunities for biology and genomics. There's an awful lot of interest in the sector right now, not just around well site remediation, but of course that's one area. So well site remediation, well sites may be contaminated with metals. I know that UBC is doing some research right now around remediation of metals contaminated sites using biology. Or genomics. It's not just metals and salts, there's also potential subsurface hydrocarbons, and what's getting a lot of airplay these days is methane migration. and methane into groundwater. So, and what's really interesting about that is that when you drill a well, you intersect methane at various levels throughout the drilling process. It's not just in the formation. You can have biogenic methane near the surface. The deeper you go, you start to interact zones of thermogenic methane. And ideally, we'd be able to identify the source of surface methane from the formation it's coming from. Traditionally, that's done with fingerprinting. So you gas spectrometer fingerprinting of the gas, and then comparing the isotopic profile of the gas with the gas from the formation, gas that you're getting at the surface with the gas from the formation, and being able to pinpoint that way. There may be other ways, and better ways, and more accurate ways through the research that's going on here to do that gas fingerprinting, I think. And the same would apply to groundwater. So we talk about groundwater, often people, I'm going to be under my 5 minutes now. When we talk about groundwater, often there's a perception, I think, among the general public that essentially once you're down 20 feet and you intersect groundwater, it's continuous groundwater of the same quality down to several kilometers, which is not the case. As we know, it's just different layers of groundwater, different qualities of groundwater. It's not even a continuum because much of it is isolated. We know that because we have contained hydrocarbon reservoirs down at 2 kilometers, so that aren't migrating to surface, at least not in great quantities. So when we start to talk about the effects of hydraulic fracturing on groundwater, we can physically monitor crack formation using microseismic techniques and show where fracture networks are created by hydraulic fracturing and show that they're confined to reservoirs, or target reservoirs. It would be increasingly important, I think, to show that even though there's no logical or visible pathway, that there is in fact no effect. So one of the primary principles in the CAP hydraulic fracture practicing guidelines that they published about 4 or 5 years ago was baseline groundwater sampling. And then a scientist would ask, well, which baseline and which groundwater, right? So, and I think that there's a lot of good research that can happen in that area as well. So, with that, I hope I didn't bore you too badly, and I think I've left about 4 minutes there. So, thank you very much.